Section 1.3 is on scientific notation. Remember that a number written in the form a times 10 to the k, where 1 is less than or equal to a less than 10, and k is a positive or negative integer, is said to be written in scientific notation. The most important part for you to remember is that in order for a number to be written correctly in scientific notation, there can only be one non-zero digit in front of the decimal point. So in front of the decimal point, there can only be one non-zero digit, okay? It cannot be zero. That's why you see there that it says a has to be greater than or equal to 1, but less than 10. Here are the examples. Write each number in standard form. For them, standard form is scientific notation. Take a look at part A. 10,807. I don't see a decimal point at all. So where is it? It's all the way at the end here after the 7. So what you have to do is say, well, right now there's 1, 2, 3, 4, 5 numbers in front of the decimal point. And I told you that there can only be one non-zero digit in front of the decimal point. So you're going to have to move the decimal point over to the left 1, 2, 3, 4 times. So the answer is 1.0807 times 10 to the 4th. And part B, look, here's my decimal point. Right in front of it, what do I have? A 0. I cannot have a 0 in front of the decimal point in order for this to be written correctly in scientific notation. So I have to take my decimal point and I have to move it this time to the right-hand side. 1, 2, 3 times. So it becomes 9.83 times 10 to the negative 3rd power. For part C, if you don't see a decimal point, the decimal point's at the end. So I have to go back 1, 2. Now, notice the number used to be 345. I have made that number smaller. I've made that number 3.45. Okay, I'm going to say that again. Right now, this number is not written in scientific notation because the decimal point is after the 5. And right now, there's 3 numbers in front, so I can't have that. So I'm going to have to move it over 1, 2 times. So 345 is becoming 3.45. This number is becoming smaller. That means that my exponent, to balance things out, is going to have to become larger. By how many? By 2, because that's how many spaces I moved. So this becomes larger by 2, so 2 plus 2 is 4. And the next exercise is we're going to be practicing what happens when I'm multiplying, when I raise to a power, when I divide, when I add numbers in scientific notation. The first one's pretty easy. Part A, 4.5 times 2.1 is 9.45. And then when you multiply and you have the same base by the rules of exponents, you add the powers. So this is 9.45 times 10 to the 7th power. Because 9.45 only has one non-zero number in front of the decimal point, then this is my answer. For part B, part C, and part D, I've done them on a separate sheet of paper for you to see. For part B, I have 3.2 times 10 to the negative 2 power squared. So 3.2 squared is 10.24. A power to a power, you multiply the powers. So notice, it looks like your answer is written in scientific notation, but it is not. Be very careful with that. So here, what I'm going to have to do is fix it. How? I have 2 numbers in front of the decimal point. I have to move it to the left 1 time, making this number smaller. It used to be 10.24. It's now going to become 1.024. I have to balance this out. So my exponent used to be negative 4. Because I moved it once and it became smaller, the power has to become larger by 1. Larger by 1 in negative numbers is negative 3. Remember negative numbers, negative 3. Negative 3 is larger than negative 4. Part C, let's go back to see what part C was. Here I am dividing, so 3.5 divided by 7.0 is 0.5. And by the rules of exponents, when I divide and I have my exponents, I have to subtract the powers. So 5 minus 6 is negative 1. So I get 0.5 times 10 to the negative 1. And again, you're like, ooh, I get this, I understand it, I'm almost done. No, you're not done because this number is not written correctly in scientific notation. Remember, there cannot be a 0 in front of the decimal point, so I have to fix it. This time around, I have to take the decimal point and I have to move it to the right one time. This number now is actually becoming larger. It used to be 0.5, think about it like 50 cents, and now it's becoming 5, like $5. So this number is getting larger. That means I have to balance it out by making my power smaller. Because I moved it over one time, it has to be smaller by 1. So what is smaller than -1? -2. Then for the last one, for part D, when you are adding two numbers in scientific notation, they have to have exactly the same exponent. So you have to make a choice. Do you want to make the 3 a 4, which would make this power higher and this number would have to become smaller, 0.5, or do you want to make the 4 a 3, making the exponent smaller, balancing it out by making the 2.4 larger, 24. So you make a choice. I mean, I chose to make the 5 times 10 to the third, keep it the same, and I chose 2.4 times 10 to the fourth, and I chose to fix it so that they both have 10 to the third power. So like I said, to fix this, to kind of adjust it so that I end up with both of them having the same exponent, the 4 got smaller by becoming a 3. So to balance it out, this has to become larger. So it's not going to be 0.24, it's going to be 24. Okay, I'll say that again. In order for me to add these, I have to have the same exponent. To add or subtract, I have to have the same exponent. I didn't care about having the same exponent when I was multiplying or dividing because I just followed the rules of exponents. But when I'm adding or subtracting two numbers in scientific notation, they have to have the same exponent. So I chose to make them all 3s. You could have chosen to make them both 4s. Okay, so because I chose to make them all 3s, the first one stayed the same, but the second one, if I'm going to make this a 3, which makes it smaller, I had to make this number larger, so make it 24 instead of 0.24. And now I add, and I get 29 times 10 to the third. And of course, I decided to choose to make them to the third, which means that I gotta fix it again. If I would have chosen the other way around, I would have gotten it already in scientific notation. But here, it's okay, it's more practice for us. Times 10 to the third, because of the 29, I have to make the 29 2.9. I have to make it smaller. I got to balance it out by making this power larger.